This is the second lecture on where does the electron go. The previous lecture looked at the pictorial method, the Aufbau diagram. Here we're going to talk about the electron configuration or configurations. Real quick review. Remember that the primary energy levels can be called orbits, and orbits can be broken down into orbitals. Orbitals can be broken down into suborbitals. Each suborbital can hold 2 electrons maximum. The lowest energy level fills first. You still need your mnemonic diagram, the one that was in your packet, and that the Aufbau diagram is a pictorial representation. Here's your mnemonic, just to remind you what it looks like. And if we look at cobalt, which has an atomic number of 27, so we get 27 electrons to place, you now know how to write the Aufbau diagram. You start with the basic diagram, and then you begin to fill each of the suborbitals in the correct order until you've placed all of the electrons. It's nice because you can see where everything goes. The problem is it's rather cumbersome to write out. There has to be an easier method. There is, and that's called the electron configuration. For the electron configuration, you only need the Aufbau principle. You don't need Hund's rule or the Pauli exclusion principle, because the electron configuration is a listing of the primary energy level, orbital, and the number of electrons in the orbital. We never mention the suborbitals. You still need the mnemonic because we need to fill the orbitals in the correct order. So let's start with hydrogen. Hydrogen has 1 electron. You'd fill the 1s first and have 1 electron. So you'd write 1 for the energy level, S for the orbital, a superscript 1, and this you would then say this is a 1s1. How about something a little more complicated? Sodium. Sodium has 11 electrons. You'd fill the 1s orbital first. It can take 2 electrons, so you would write 1s superscript 2. The 2s orbital then fills. You can put 2 electrons there. So now you have 1s2, 2s2. The 2p orbital is next. You can place 6 electrons and it would be written as such. We have 1 electron left to place. We see that 3s is next. So you would write it this way, and you would say that sodium is 1s2, 2s2, 2p6, 3s1. If you add up all of the superscripts, you notice that it comes out to be 11. 11 electrons. Matches up with what you need to have. You got it all done. Let's go a little more complicated. Zirconium. 1s gets filled first, so you get this. You see from the mnemonic that 2s would get filled next, so you now have 36 electrons to place, and you have placed 4. 2p followed by the 3s. Now you know that the 3p gets filled. After the 3p, the 4s gets filled. After the 4s, it's the 3d, then the 4p, then the 5s, and the last 2 electrons go into the 4d, and you would most likely leave it in this format: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d2, and I would accept that as a correct answer. But a more correct answer is when you put all the energy levels together like this. Either way is acceptable. Okay, an example for you. What is the electron configuration for sulfur? Go. The first thing you should note is that sulfur has 16 electrons, and the answer you should have gotten is this. If you do it out, you start with the 1s being filled first, followed by the 2s, the 2p, the 3s, the 3p, and you notice the subscripts all total to 16. Okay, more complicated. Xenon. Go. Xenon has 54 electrons. You most likely wrote it like this. I would have written it like this. I'm not going to go through it step by step, but if you need me to, please see me during class time. I would be more than happy to go over this with you. So in review, the Aufbau diagram is pictorial. The electron configuration is a list. With the electron configuration, you only need to follow the Aufbau principle. And if you break the Aufbau principle, then you have an atom which is in the excited state. If you add up the superscripts, it better equal the number of electrons you had to place. That does it for where the electrons go. We're going to move on to a slightly different topic in the next set of lectures, which are on light and energy. And then we're going to tie it all up together in the last lecture on something called atomic spectra.